All right. Hello, everybody. I'd like to welcome you all to the symposium on cheating, fraud, honest lies, and omission in Mechanical Turk data. I am David Hauser. I am a grad student at the University of Michigan, and I'm also the chair of the symposium. And today, we're going to present some interdisciplinary research on methodological advantages and some considerations to take in mind for MTurk studies. The lineup that we have today is first we'll have Scott Clifford, who is a professor of political science from the University of Houston, and he will start off by talking about how often MTurkers cheat on knowledge questions compared to other samples. Then Jesse Chandler, who is also the co-chair of the symposium, and he is from Mathematica Policy Research. He will talk about how often MTurkers lie in order to fraudulently gain access to your surveys on MTurk. Then I will talk about how attention checks on MTurk may potentially create context effects and make honest liars out of MTurkers. And then finally, Ayelet Fishbach, a professor of behavioral science and marketing from the University of Chicago, will discuss how attrition and omission on MTurk can actually potentially generate false conclusions in your research. So all of our talks will highlight important considerations for all of us researchers who use MTurk, and we will also try to discuss some remedies for these issues that we raise. But without further ado, let me present Scott Clifford from the University of Houston.
All right, thank you, David. So what I'll be presenting today is based on a couple of papers that I've published already, co-authored with Jennifer Jarrett, and some additional work that's ongoing. So I'll just be highlighting a few pieces of this work that I think is most relevant to all of us here. So let me just start. I'm focusing on political knowledge. In political science, this is really important. It helps us predict how attitudes are structured, how people process information, who is polarized. It's a really important topic for us, but even though I'm focusing on political knowledge, everything I've seen in the literature on this topic suggests that it applies to other types of factual knowledge as well. So I don't think this is just relevant to politics. So as our research is shifting more and more online, especially to MTurk these days, people are starting to worry about cheating. Are people just Googling the answers, looking things up, and screwing up our measures? Now, initially, people said, we shouldn't really be worried about this. Look, the thing we're worried about is satisficing. People aren't motivated to even do a good job answering the survey, let alone to spend extra time and effort looking up answers. So a lot of people said, we shouldn't worry about this. And some of the existing evidence is pretty mixed on this. People looked at mode effects and said, look, knowledge tends to be a little higher online, but this is probably just a sample effect. These people are just different. But when I first got into this, I started with a student sample and randomized students after they had agreed to participate in the study to either take a study online or in the lab. And here's just the distribution of political knowledge by mode. And as you can see, if you look at the two right-hand bars there, people in the online were a lot more likely to get 7 or 8 out of 8 questions correct. So evidence we thought that there's a lot of cheating going on. So why are people doing this? If it's extra effort into a survey that we know that they may not be putting that much effort into in the first place, why are they doing this? There should be weak social desirability pressures if this is an anonymous online survey. So it's not like they're impressing someone with these with their knowledge scores. But recent literature suggests that we sort of think about our knowledge in a different way when we're interacting with the internet. We use this sort of as a transactive memory partner. So we may not remember all of these facts, but we know where to find it. And the problem is we don't make a clean distinction between what we know and what we know how to find. So people feel as if they know these facts, even if they do have to look them up. And so studies show that when people are told to look up the answers, they sort of take credit for that. They feel smarter. They feel like they know more. So it may be that people just aren't distinguishing between these two. There seems to be some reason behind this, but we do think there's going to be variation across populations. So we thought that students would be the most likely people to cheat, and indeed that seems to be the case. They have a lot less in terms of time pressures. Students don't really have have that many responsibilities compared to other people. They're young and tech savvy. Now, Turkers tend to be fairly young and presumably tech savvy as well, but they have a lot more in terms of time constraints. They spend a little extra time Googling an answer or asking someone for an answer. It means they might miss out on taking another study, right? So we think that that incentive there is going to reduce cheating among this population and maybe make it less of a problem among MTurk than other samples. So how do we know? This is really hard because we can't observe what they're actually doing in the privacy of their home or wherever they're taking these surveys. So we started just by asking them whether they cheated. Not a perfect method, but this should give us like a lower bound. We at least know that that many people are cheating. And people are surprisingly willing to tell us that they looked up answers. So this is just the cheating rates across a lot of different samples where we've tested this based on self-reports. If you look at the dark bars on the left hand, those are all our student samples. Self-reporting cheating rates range from 20% to 40%. Recently, I got a sample with 60% telling me they cheated. So this is a huge problem in student samples. In the middle, we have 2 nationally representative samples and a campus staff sample. Here we get about 13%. And I'll point out that with the CCS sample, this is actually verbal knowledge, the word sum battery, and it's about the same cheating rate as political knowledge, suggesting this is not just a politics thing. And finally, when we look at Turkers here, we get cheating rates between 4 and 7%, so our lowest cheating rates out of all of these. So that's good news for MTurk then. But you might wonder, well, can we really compare these self-reported cheating rates across samples? Maybe MTurkers are just lying about this more. Legitimate concern, and I'll circle back to that in a little bit here. But first, I want to just address the question, well, if people are cheating, and obviously they are, what do we do about it? The first thing we did was just ask people not to cheat. Just tell them not to do it, and it was completely ineffective. It didn't, not only did it not affect their knowledge scores, it didn't even affect their self-reported cheating rate. They cheated and told us they cheated. So that was a bust. So next we tried something for giving language, tell them not to cheat and explain these questions are really hard, it's okay, if you don't know the answers. We tried a timer, give them only 30 seconds to answer each question. And finally, our preferred method, we tried a commitment question, ask them if they're willing to answer the questions without cheating, give them a yes or no option, and then hope they want to maintain consistency with that. So here's what we find on the far left are self-reported cheating rates. All 3 treatments here substantially reduced self-reported cheating. Our commitment mechanism was the most effective. Forgiving language was the least effective. All 3 of them reduced knowledge scores as well as time taken answering the questions. So they all seem to be working. The commitment question seems to be working the best, and in some other studies we show that the commitment condition improves the predictive validity of the knowledge scale, both relative to a control condition and relative to the timer. So we don't really like the timer because it seems like that time window is not just deterring cheating, but it's also making it harder just to answer the question. It's interfering with the usual response process, we think. Okay, so let's come back to that question about Turker self-reports. Can we really trust this? A recent paper came out by Mata et al. That used a different method of measuring cheating. They used something that I call a catch question. So they asked something really difficult, like what year was the Alaskan Purchase Treaty signed? And they ask for an open-ended response. So if you give exactly the right answer, which I think is 1869, they assume that you cheated, that you looked up that answer. So it may not be perfect either, but at least it shouldn't be biased from self-reports in the way this other measure was. And they found a 25% cheating rate on MTurk. So this got me really worried that maybe I had screwed everything up here and I was wrong, so of course I had to figure out whether I was wrong. So I ran another study on MTurk here, giving them both measures of cheating, and so I can compare these, and here's what I found. Similar cheating rates based on both measures. So a little bit lower, about 22% on self-report and about 28% on the catch question. I've compared these 2 measures in lots of samples now, and they give very, very similar rates of cheating. So it doesn't seem to be a problem with self-report. So that's the good news. The bad news is that in this MTurk sample, I had fairly high cheating rates. So it seems to be varying a lot across study, even within a particular population, and I'm not sure really why yet. But the good news is here, I also gave them the commitment condition, and it reduced cheating substantially according to both measures. So for both measures, we see a 20 percentage point drop in cheating rates. So that commitment question is working still. That's the good news. Yes, that's right. So everyone got both measures, and we're comparing the same group of people, yeah. Okay, wow, I really sped through that. So just to wrap it up then, cheating seems to be pretty common, a lot more common than people expected at first, especially among student samples. If you're using a student sample online, I think this is a really big problem. And evidence suggests that it's really compromising the validity of these measures. It's not predicting what it should predict as well anymore. It's not as much of a problem on MTurk, so that's good news, but it can be. Right? We've now seen a lot of variation across studies on MTurk and what those cheating rates are. And I don't really have a good answer as to why that's the case. I can speculate on this, though. The thing that made this last study I did stand out that gave a lot higher cheating rates is that it was right before the election, and the study began by asking a lot of questions about vote choice and partisanship. And so I wonder if that's what drove up cheating rates. People just told us who they voted for, and they wanted to sound like they're informed, and they actually knew what the hell they were talking about. And so that may have driven up cheating pressures. So I think there are a lot of interesting questions to be answered in terms of why people are cheating and why certain studies will find this and some studies won't. But that'll be up to future researchers, I think. But I guess the takeaway is to use the commitment question. That's the best thing we found. And we've also tested people don't react negatively to it. They don't seem to be upset by it. In fact, they'll leave you comments, and they seem to sort of enjoy that. It's like a challenge for them. So that's what I would suggest using. So thank you. Yeah. Uh-huh. Right, yeah, so I guess I should have said that I'm using the term cheating loosely. It isn't necessarily cheating, but the fact that when we explicitly tell them not to cheat, they still do it anyways, suggests to me that it's not just that they don't know they shouldn't be looking it up. Right, so right at the very beginning of the knowledge questions, we say, we have some factual knowledge questions. Please don't look up the answer or get help from any other source. Okay, so then the commitment question is above and beyond. Right, right. So that simple instruction not to look up answers has virtually no effect in the studies we've done. Yeah. Mm-hmm. Yeah. Yeah, that's what I was worried about. But the fact that these self-reports line up so well with the estimates from the catch question, and it does so both in MTurk samples and in student samples, so that suggests to me it's not a problem of differential lying on MTurk. Yeah. Yeah, good question. Across several studies, when I've looked at that, the correlation is about 0.7. They both do seem to capture unique variants in cheating behavior. So if the thing that you really want to do is measure cheating, I'd say use them both. Yeah.
Do you think this also extends to non-knowledge questions such as random clicking? Would that also influence that, or is it like a distinct type of commitment question?
Such as, what was your example? I'm sorry.
Randomized clicking.
Randomized clicking.
Like people are just clicking on lots of scales, just random responses.
I don't know. I think there's a lot less pressure if they don't think there's a right or wrong answer to something. You know, if you ask for an open-ended question about, you know, what do you know about this policy or something, or what are your attitudes, I don't think there's that same pressure. And there's no clear, what am I supposed to be Googling either. So I suspect it's much less of a problem, but I don't know for sure. Yeah, that's a good question. So I've looked among individual items to try to figure out, are there some that people cheat on more? And I haven't seen any really clear pattern. Of course, if it's really easy, there's no need to cheat. I do think that catch questions aren't perfectly representative of cheating. You know, people may cheat on all of the questions but that one, or people may answer them all honestly and still cheat on the catch question. So that's not perfect either. But I don't have a good sense of which questions people cheat on. So, yeah. Thanks.
All right, up next we have Chandler, who will talk about another form of sort of cheating, fraud.
All right, so today, like David said, I'm going to talk about honesty on pre-screening questions. So these are questions where you're trying to determine eligibility for a study that you're conducting. And I want to draw particular attention to the sort of counterintuitive situation that can occur where most respondents are answering these questions truthfully, yet most of the people who screen into your survey are in fact fraudulent. By pre-screening fraud, I basically mean people who are lying to gain access to your survey. And what I hope you'll take away from today's talk are a few different things. So first, I hope you'll recognize that fraudulent respondents may be more common than we may assume. I'm going to show you that higher incentives, in fact, increase rates of fraud when you're conducting surveys. I'm going to look at some of the reasons why fraud prevention measures may be less than perfect. And I hope you'll sort of get a sense that even low fraud rates can be bad, but this problem is manageable. So there are things that we can do to mitigate, if not eliminate, fraud. And when we're recruiting specific groups, we need to be very conscientious about how we're trying to reduce fraud. So I'm going to start just by illustrating what I mean when I say that most of your respondents can be honest, but many of your eligible responses can be frauds. One way that you can look at fraudulent behavior in pre-screening items is to simply manipulate whether participants think that they're taking part in a question that determines their eligibility for future studies. In this particular study, what we did was we asked participants who were mostly parents taking part in another survey a single question. We asked them, are you the parent or guardian of a child who's been diagnosed with autism? Importantly, we asked this in two different ways. And for half these participants, we asked them this as a part of a larger set of demographic questions. And then for half of the participants, we led the question by first saying, we're looking for people to take part in a future study. And then we followed up with the question asking them whether or not they had a child who was diagnosed with autism. The intuition here is that when people see this question, they'll kind of have some idea that we're looking for people who belong to the rare group. And then you can measure rates of fraud by looking at differences in the incidence rate of parents who have children with autism across these two groups. And so when you do that and you take the difference, you find that the incidence rate of parents who say they have kids with autism is about 3.5% higher in the pre-screening group, right? So this is pretty good, right? We live in a world where something like 97% of respondents are honest when they're answering these questions, and that's great. However, when we're pre-screening, we don't actually care about how honest participants are in general. What we care about is the positive predictive value of our pre-screening measure, and this is determined not only by the rate of fraud, but also by the base rate of the population that you're trying to recruit. In this particular case, it turns out that maybe about 4% of the sample of parents actually have a child diagnosed with autism, And what this means is if you're pre-screening for these individuals, you could find yourself in a situation where something like 40% of your sample consists of fraudulent respondents. You might think that this is not a particularly great way to pre-screen people into a survey to sort of blatantly tell them up front who you're looking for. But I will note that this is something that actually happens quite a bit. If you take a look on MTurk and look at how people are recruiting, it's very easy to find examples of people engaging in this kind of activity. Some of these people are very smart. So here's an example from someone from Yale. And some of these people are looking for very specific, some of these people, or researchers recruiting people in this manner, are looking for very specific groups. So here's another study where people are looking for Mechanical Turk workers who've been diagnosed with lymphoma, which is an incredibly rare group. I mean, this kind of approach has no hope of finding a truly honest sample. Usually when we're pre-screening, if we're clever, we try to do something a little bit more subtle. So, you might think that you could ask participants a bunch of questions, and then based on the responses to those questions, you could either route them through to your survey or tell them that they're ineligible and in fact kick them out. I'm going to show you what happens when you do that in this next study. So in this study, we asked all participants at the beginning what their biological sex was. What we didn't tell them is we in fact had that information. These were all participants who'd participated in prior studies that we'd done, and we had a sort of gold standard of what they said their biological sex was a few weeks ago, a few months ago, or whatever. When participants honestly indicated what their biological sex was, that is their self-reported sex was consistent with their prior report, we actually told them, oops, sorry, you're not eligible for the survey, and we terminated them. And so our dependent measure of fraud in this study is whether participants then come back and reattempt the survey. So we're looking at workers who are attempting the survey multiple times and then changing their responses until they actually successfully screen through. In the study, we also manipulated the incentive level. So about half of the participants were paid a quarter for this 5-minute study. So that's about 5 cents a minute. It's half the recommended rate on Mechanical Turk. And then half of the participants were paid 20 cents a minute, which is about double the recommended rate. And what I'm showing you here is that incentives motivate behavior, right? So economists are right about this. Fraud rates increase as you increase the rate of pay. And so this suggests that this is something that you have to be very careful about if you're sort of trying to recruit more participants by offering more payment. One of the trade-offs of that may be that fraud rates are increasing. Another thing that's kind of interesting about this study and kind of goes back to what Scott was talking about was that at the end of the study, we asked all participants, is there any reason that we should exclude your data? If so, just check this box. It won't affect whether we pay you or not. But we just want to make sure that we have a good sample. And none of these participants indicated that we should kick them out. So so we can't really rely on participants to self-report and indicate to us that they're fraudulent. So there's also technical methods of reducing fraud rates. And I'm going to show you what happens when you use one of those methods in this particular study and show you some of the implications it has for reducing fraud. In this particular study, it was framed as a study of technology use and personality. And so we began the survey by asking participants to select all of the electronic devices they owned from a list. So this is things like tablets, smartphones, HD TVs. And importantly, one of the items on this list was an Oculus Rift virtual reality headset. Participants who did not indicate that they owned an Oculus Rift headset were terminated from the survey. And then participants who did indicate that they owned this headset were allowed into the survey. Importantly, in this survey, we randomly assigned participants to one of 2 conditions. In one condition, it was sort of the business as usual method, where we didn't make any efforts to reduce pre-screening fraud through technical means. And then in the other condition, we used a feature that Qualtrics has called prevent ballot stuffing. This is a feature that basically places a cookie on the respondent's browser that prevents them from reattempting the survey. What I'm showing you here is that when you make no effort to prevent cheating, you get a cheating rate of around 20%. And then as you might expect, when you turn on this prevent ballot stuffing feature, fraud drops dramatically. It's actually about 3%, I think, here. What's more interesting about this particular graph is not that the fraud rate drops to 0, or drops significantly, but that the fraud rate is in fact higher than 0. because of how prevent ballot stuffing works, there's actually many different ways you could defeat it, right? So you could clear your browser cache, and that lets you reattempt the survey. You could open up another kind of browser, so close Chrome and open Internet Explorer, and you're still eligible to take the survey again. Or you could just close one device and go on another device and take it there. What I'm showing you in this graph on the right is the percentage of fraudulent respondents. So these are people who ultimately indicated that they owned this headset who are fraudulent relative to people who are honest. And the point of this is just to illustrate that when you're recruiting a very rare group, it's very easy to end up in a situation where almost all of the respondents you're collecting data from are in fact frauds. What I'm showing you here is what happens to the fraud rate when you prevent ballot box stuffing. Of course, it drops, but one thing to note here is that it doesn't drop as much as you might think it does if you were looking at the graph on the left. This is just a function of the different numerators and denominators and how base rates work. But in this particular case, even if you're sort of engaging in best practices and really trying to prevent fraudulent respondents, because the group's rare, half of your sample is still not who they say they are. So that's just within the context of one study, right? But fraud prevention is difficult too because people learn over time, right? This isn't the first survey that these people have taken, nor will it be their last. And as participants or MTurk workers engage in multiple different surveys, they have opportunities to learn the kinds of things they need to say to get into a study. And I'm going to show you some data here that sort of supports that. In this particular study, what we did was we re-recruited people who completed the Oculus Rift survey that I showed you, or the Oculus Rift study that I showed you earlier. And when you look at these individuals, about 2% of them could be thought of as honestly owning an Oculus Rift headset. So these are people who indicated that they owned one of these things on their very first attempt of the first survey. And so what I'm going to show you next is that when we re-recruited people 1 week later, 20% of people indicated that they owned an Oculus Rift headset on their very first attempt of the survey. So you would have no indication that these people were acting fraudulently unless you were able to go back and cross-validate the responses against the data collection that you happened to conduct earlier. What's also interesting is that not all of these respondents were people who cheated the first time around. In fact, about half of this increase is attributable to people who were screened out of the first survey, went away, never cheated, but then when presented with a new survey, then engaged in the opportunity to cheat. So these aren't even individuals that you would necessarily be aware had completed your previous surveys unless you're actually recording their worker IDs when they were in the data file on Qualtrics as they attempted to complete their data, or complete your survey. What I'm showing you here is cheating rates 5 weeks later. Again, self-reported ownership of an Oculus Rift headset on their very first attempt of the survey is suspiciously and significantly higher than the ownership rates indicated on the very first attempt of the survey previously, but it's also significantly lower than the 1 week later condition, which indicates that there's probably some sort of forgetting effect happening here. It's kind of hard to remember the survey that you completed 5 weeks ago, particularly if you've completed dozens and dozens of surveys since. So, clearly fraud is bad, right? Clearly situations where 90% of your sample aren't who they say they are, that's like a bad situation. It raises very serious questions about the validity of the data that you're collecting. But what I want to do now is kind of work through a bit of a thought experiment to think about the kinds of impact that the sort of unavoidable low level of fraud can have on your data collection effort, right? So we can mitigate fraud, but it's hard to eliminate. And so what does it mean when there's fraud in our sample? What do we need to do to offset it? And so what I'm showing you here are results from a simulation study. This is basically assuming a world in which we have a population of interest where there's a correlation of about 0.2 between two different variables that we're interested in, any arbitrary two variables. And then there's a sample of imposters as well. And within this population, the correlation between those two variables is 0. The blue line here is the sample size that you would need in order to attain 80% power in this world. And the orange line represents the statistical power you would achieve if you didn't do anything to change your planned sample size. So if you have a fraud rate in this world of about 10%, you have to increase your sample size by around 11% to offset this. And this is assuming only that you care about having a p-value that's less than 0.05. This is ignoring any sort of concerns that you might have about whether you want to get the right effect size estimate, right? This is tolerable, right? In this case, it would mean you'd probably need 25 extra people just built into your sample calculations to offset fraud if you thought that this is what your fraud rate might be. There's another reasonable scenario, though, where fraud rates are 25%. And in this case, you need to increase your sample size by around 35%. 25% sounds like a high fraud rate, but it's not terribly hard to get there. If you'll recall back to the Oculus Rift study, we're able to sort of limit fraud to about 3% in that particular condition. And what that means is that you would expect a fraud rate of around 25% when you're recruiting a population that has an incidence of about 9% in the Mechanical Turk population. And so these are not rare, these are uncommon groups, but not rare groups by any means. You know, these are that kind of incidence rate is what you might expect if you're recruiting African Americans or people who identify as LGB or maybe even Republicans, right? So groups that we care about, groups that we do a lot of research on, groups that we're interested in. And as you can also see, you know, as fraud rates go up, the impact on the sample size and power kind of increase exponentially. And so that's why it's really important to try and minimize fraud. Uncommon groups also, I just want to note, are like kind of doubly cursed. So, you know, not only are they especially sensitive to the prevalence of fraudulent individuals within their sample, but also you have to screen that many more individuals to find them. So if you're going after a group that there's only 10% of them in the Mechanical Turk population, the extra 65 or so people you would need to increase your sample size by 34% in this example would require screening an extra 650 people, right? So it's easy to imagine a situation where you just can't compensate for the fraudulent respondents in your sample. I just want to note quickly that this goes beyond MTurk. I mean, I'm studying this in MTurk because it's an interesting sample for me and because it's possible to uniquely identify respondents, but these issues are probably, to be expected anytime we're relying on self-report data to recruit participants in the studies. This includes not only online, but it also includes when we're sort of posting flyers around campus, telling people that telling potential participants that we're looking for people who say that they're depressed and we're willing to pay them $50 to come into our lab, right? So you have to be really careful when you're doing that kind of recruitment activity. There's examples of this kind of fraud in other pools. So for example, in market research studies show that 13% of Americans claim to own Segway personal transporters. If you can't think of 13% of your friends who own one of these things, you know, you shouldn't feel surprised. Perhaps more interestingly, studies of medical research pools find that a quarter of participants indicate lying about their symptoms to screen into medical research trials. And this is actually a really fascinating paper because when they ask people how they do this, they report all sorts of things, including going online and reading the pre-registration materials to figure out the inclusion criteria, sharing this information with friends, and also the sort of repeated recruitment attempts that I demonstrated here. There's a couple of different things we can do to mitigate fraud. I think probably the best thing you can do is pre-screen unobtrusively, so don't tell people that you're looking for a specific group. And importantly, you want to make the entire experience of participating in the study set up in such a way that people aren't aware that they are ever pre-screened. So probably the best way to do this is to route people into one of two surveys. If they belong to a rare group, they go into the survey that requires people who have those particular characteristics. And if they don't, they just get routed into a more general survey with no inclusion criteria of a similar length. So that way they complete the survey none the wiser that they were ever involved in a pre-screening effort at all. And I definitely think that when you're working with these rare populations, you have to report what kinds of steps you're taking to eliminate or mitigate fraud. Because as you can see, you know, it's very easy to run into situations where fraudulent responses are high, and you just can't evaluate that as a reviewer unless you have that information. And finally, just one piece of MTurk specific advice. I think what all of this suggests is it's really important to start linking individual survey attempts to specific worker IDs so you get a sense of which workers are providing which data and which data in your data file is non-independent. It'll give you insight not only into fraud, but a lot of other potential problems that are happening in your survey. So thank you for your time, and I don't know, do we have time for a question or? Okay. All right, thank you.
Okay, all right, well, thank you very much, Jesse. So my name is Dave Hauser. I'm a graduate student at the University of Michigan, and what I want to talk about is how certain questions on MTurk can potentially create context effects within your studies. So this talk today is actually all about sort of one question, and it looks like this. So if you're not familiar with this question, this is called an instructional manipulation check. It's abbreviated IMC. I'll use that. I'll say that throughout this talk. Some people call these attention checks or trap questions. And the reason that it's important is because it's a question that researchers will frequently include in their MTurk studies. So if you aren't familiar with it, or if you can't read that tiny text, here's how this works. On the surface, it just looks like a question about what sort of sports you like to play. But if you actually read the instructions in the middle closely, what you'll see is that the question says that this is actually about attention. And in order to demonstrate that you've read the instructions, what you're supposed to do is ignore all the sports items below. Instead, you click the box marked Other, and then you type in I read the instructions, and then you click Continue. There's a lot of different questions that take this different format, where you have a question that on the surface just looks like it's something normal, but then hidden within the instructions are these pseudo instructions that actually give you what you're supposed to do. And the idea behind this question is that the MTurker who follows those instructions, who types in I read the instructions, they get this question right, and it's assumed that they pay very close attention to your research materials in your survey. And the MTurker who doesn't do that, they obviously get this question wrong, and it's presumed that they're not paying very close attention to your study. You might not want to include their data within your sort of data set. And the idea is, because of all of that, because of this question's ability to measure attention, you should include it in your MTurk studies, because we all know that we're very concerned about whether MTurkers are paying attention or not. But there is an issue here with this question, and that is that it's actually a really odd question in the context of a survey, right? We can think of surveys as basically being conversations between researchers and participants. And participants infer things about the survey, and they infer things about the researcher based on the things that we ask them, right? So the idea here is that this question might actually tell MTurkers a few things about the survey that they're about to take. One, it might tell them that there might be more than meets the eye to questions. There might be something lurking below the surface that's not readily apparent to them when they first encounter any given question. And two, it tells MTurkers that they might have to go against their intuitions in order to be right on a question. That's how you get the IMC right. That might be the case for other questions in this survey. So the issue is that IMCs might not be these mere measures that we can drop into our surveys and not have to worry about them affecting participants' responses. They might actually create context effects that cause MTurkers to respond with less intuitive options than they normally would, because these questions basically train them to do that. So that's what we investigated in our studies, and that's what I'm presenting some data on. So in our first two studies, we looked to see how IMCs actually affect reflective reasoning tasks. These are the sorts of tasks where going with your intuition is something that hurts you and makes you get a lower score. And IMCs might actually create context effects that improve people's performance on these sorts of tasks. So in the first study, we looked at the cognitive reflection test, it's also abbreviated the CRT. And this assesses whether people go with the first spontaneous answer that jumps into their head, or whether they reflect on it in order to get the actual correct answer. So this problem about lily pads is one of the questions on the CRT. The answer that leaps into people's mind when they read it is 24 days, but the actual answer is 47 days. And it requires a little bit more reflective reasoning in order to say 47 days. The second task that we looked at was the denominator neglect task. This also assesses reflective reasoning. And in this task, you tell participants that you can draw a black marble to win a prize, but you can only choose to draw from one of two trays. The large tray is the intuitively appealing response because it has more black marbles. But since we all know about probability, we know that the small tray is the optimal response because it gives you a better probability of drawing a black marble. And people who are thinking reflectively tend to choose the small tray in this denominator neglect task. So in our first two studies, we recruited over 350 MTurkers for each of them, and we wanted to look for context effects of IMCs on these reflective reasoning tasks. So, for example, in the first study, we gave MTurkers both an IMC, an instructional manipulation check, and we gave them the CRT, the cognitive reflection test. And what we did is we just manipulated the order of the tasks. So for half of our participants, they got the CRT first, followed by an IMC. The other half of our participants got an IMC first, followed by the CRT. And the logic here is that if the IMC is just a measure that you can drop into your survey and you don't have to worry about it affecting how participants reason about tasks, then people's CRT scores shouldn't be affected by the order in which they get these tasks. But if IMCs actually signal that there's more than meets the eye to questions, then MTurkers might do better on both of these reflective reasoning tasks when they come in this second order, so when they come after an IMC. So here are the results for our first study. On the y-axis is the mean CRT score per group, and higher scores mean more reflective thinking. And what we find is that when MTurkers get the cognitive reflection test first, they have a baseline CRT score of about 1.3. So without any preceding questions, this is how MTurkers tend to score on the CRT, at least when we gave them this task. But when we first give MTurkers an IMC and then we give them the CRT, we find that their CRT score jumps up by about ½ a point to a score now of 1.8. That's about a 40% increase in their CRT scores. So what we're finding is at least some initial evidence that an IMC is increasing cognitive reflection. It's creating a context that is improving performance on some reflective reasoning. And because the CRT has some links to IQ, we could potentially say that giving MTurkers an IMC is actually making them a little bit smarter here. In the second study, we find a very similar effect. So on the y-axis is the percentage of MTurkers who choose the optimal tray within this denominator neglect task. And what we find is that when this task comes first, about 60% of MTurkers make that choice. But when we first give them an IMC and then they complete this denominator neglect task, now about 75% of them are choosing the optimal tray here. So again, IMCs are creating these context effects. After participants respond to an IMC, their performance on a couple of reflective reasoning tasks seems to improve. And what we seem to think here is that IMCs are causing MTurkers to give more non-intuitive answers in response to a question. But the interesting thing is that if that's the mechanism, then what we should expect is that the context effects of IMCs will depend upon the nature of the task that follows an IMC. So they should improve performance, they should make you do better on tasks that are where the right answer is something that is reflective, but they might actually hurt you on tasks where the right answer is something that's intuitive. It's something that's simple. It's something that's really obvious. So that's what we looked at in our next two studies to see if IMCs could actually undermine performance on tasks where the right answer is plainly obvious. So in our next study, we recruited over 600 MTurkers, and we simply asked them this question. So we asked them, how many numbers are there in the following sequence? We gave them numbers organized like this, and we gave them a text box to put in their answer. Now, it should be pretty obvious what the answer to this question is, and it's 10, right? So when we pilot test this question, we find that most MTurkers give this response, and when they do that, they do so relatively quickly. So this is a pretty intuitive way to respond to this question. But what we also find in our pilot testing is that a proportion of individuals will actually give a different answer, and they'll say that there's 21 numbers within this sequence. If you're wondering how you get to that, if you count up the number of digits there total, there's 21 single digits instead of 10 whole numbers. And what we found in our pilot testing is that this was the second most common response that we saw, and people who gave this answer took significantly longer to give this answer than those who said 10. So this is a relatively non-intuitive way to answer this question. So this question has both this intuitive and non-intuitive answer, and in our actual study, we give MTurkers this question along with an IMC. We vary the order to look at these IMC context effects on non-intuitive responses. And here's what we get. So this is the proportion of MTurkers who give one of these non-intuitive 21 responses as a function of the order of the tasks. And what we find is that when MTurkers get this numbers question first, only about 4% of them, just like in our pilot testing, give an answer of 21. But when we first give them an IMC, then we ask them how many numbers, and we now find that 8% of them give one of these weird responses of 21. It is only a 4 percentage point boost, but if you're thinking in terms of rare responses, we're actually getting a 100% increase in the number of these rare responses. And overall, this actually suggests a pretty interesting pattern, right? So IMCs, they're not causing MTurkers to be more careful and give more correct, considered answers. What they're doing is they're causing them to sort of go against their intuitions and endorse more non-intuitive responses. And here that's having that odd effect of making more of these odd responses in a task that has a pretty obvious response to it. Before we were finding that IMCs are making MTurkers a little bit smarter. Here we could say that they're making them a little bit dumber and respond with more of these weird, bizarre answers. So in our fourth study, we did a very similar thing. Again, we recruited over 600 MTurkers, and we gave them this question, but we tweaked the wording a little bit. So instead of asking about how many numbers, we asked about how many numerals. When we pilot tested this question, we found now that actually both 10 and 21 were common responses because this is a less conventional way to ask this question. So both of these responses were given relatively quickly. They're rather intuitive responses. And there's actually a number of other ways that MTurkers responded that took significantly longer than saying 10 or 21. So for instance, MTurkers would hedge. They would say it's 10 or 21, or they would say it depends. Remember, we gave them a text response box, so these responses were possible. Or they would give really odd answers like saying that there's no numerals within the following sequence. I'm not quite sure how you get that answer, but people would give it. And we classified these other responses as being non-intuitive ways to respond because they're obviously less conventional, they're less easily explained, and they took significantly longer for participants to generate. And then in this final study, just like before, we gave MTurkers this question along with an IMC. We varied the order to look at these potential context effects, and we get a very, there we go, and we get a very similar effect to what we found before. So when this numerals question comes first, about 15% of MTurkers give one of these weird other answers. But if we first give MTurkers an IMC, then we ask them how many numerals are there. Now we find that 25% are giving one of these bizarre other answers like hedging or saying that there's no numerals in that sequence. So again, we find for the fourth time now that answering an IMC is causing MTurkers to give more of these non-intuitive answers. It is increasing these non-obvious answers in response to one of these pretty simple questions about how many numerals there are. So the interesting thing is that we do know that IMCs are very effective measures of attention on MTurk. And because of that, they're very recommended to be used in MTurk studies. But what this research suggests is that we do need to be aware that these questions change reasoning strategies of our participants. They teach MTurkers that they might have to go against their intuitions to be correct, and that changes how they respond to questions. It improves their performance on tasks where reflective reasoning is actually valuable, but it leads to more of these weird answers on questions that have pretty obvious answers to them. And this suggests that there's actually a wide range of outcomes that IMCs could potentially affect. Any task that involves going with or against your intuitions is a potential candidate here. And as we know from dual process models like the ELM, there could also be interactive effects of IMC exposure within your studies that you wouldn't even know about unless you varied the order or you either included it or didn't include it. So IMCs do pose an issue that we do need to be aware about or aware of in our MTurk studies. So now for the more, how can we alleviate these effects, right? Now that I've pointed all these out, what can we actually do about them? Well, the obvious answer is that if you must use an IMC in your survey, then save it for the end of your survey. Putting it at the end is obviously going to prevent any of these context effects. But do know that IMCs at the end of your survey also have drawbacks. So they could potentially be overly conservative measures of attention. Attention at the end of your survey might not be representative of attention throughout your survey, so there are issues with that. And that leads me to my other suggestion, which is maybe just don't bother using IMCs on MTurk. Most people use them because they are concerned that MTurkers are inattentive, they're not paying attention to their materials, and I need to make sure that they are attentive. But research is actually showing that doing something simple on MTurk, like setting a 95% hit acceptance ratio, gives you a very attentive sample of MTurkers. they actually test out as either being equally attentive, if not more attentive, than college student participants. So this assumption that MTurkers are inattentive might not be something that we need to keep perpetuating. IMCs might not even be necessary on MTurk if you use the proper restrictions. They might be solving a problem that we don't actually have. So in the end, what I want to leave you with is the idea to just be careful with your trap questions and your IMCs, because they're not just measures, they are also potential interventions. So thank you very much. And I think we have time for a few questions. Yeah. So the question, or at least the comment, is possibly, so that the IMCs could potentially be making people look up the answers to something like the CRT. Right. That's a fair point. I will actually mention, I didn't have time to include it in this, but at the end we kind of did a similar question to Scott, where we asked them, did you look up the answers to this? Did you Google it? And we do get people who Google it, but it's not actually different between conditions. So it doesn't seem like giving them an IMC is driving them to Google to figure out what the actual answer is. Yeah. The correct answer of saying 10 numerals? The correct answer to that question is 27 numerals? I don't quite understand the correct answer as being 27, so maybe we can talk about that afterwards, but, and we can, oh, 21, oh. Does it change the percentage of them who say 21? Yes, because that's in the other category, right? So it increases the number of non-intuitive answers, which means it also decreases the number of those correct answers. It acts on both of them. Both 10 and, yeah. Actually, I'm afraid I'm out of time for questions, so I'd like to introduce Eilert Fischbach. There you go.
All right. Thank you. Good morning. I'm actually here filling up for Hao-Tian Zhao, who's my colleague on this paper, the person that is listed in your program and couldn't get a visa, so he's not here. Well, what I'm going to talk about is the unattentive selective attrition that's causing us problems in the experiment, or as Hao-Tian and I like to think about it, Donald Campbell's demon in the time of MTurk. And basically, as you all know, because you are here, there is an explosion in web experiments over recent years, especially on MTurk, not only. Just to give you some numbers for that, if you can see these figures, between 2012 and 15, we got to between 40 to 50% of the papers in JPSP and PSPB reporting at least one MTurk study. There was also an increase in other journals. We looked at psychological science, although it's mainly in social psychology and personality that we see so many studies run online. And the problem is that these studies often violate the assumption of random assignment, basically because participants' attrition, quitting the study before finishing it, is common, and it varies systematically across experimental conditions. So let me start with the personal story of how I got to it. We were running a study. It was a very simple study. It was a mood study with positive mood and negative mood, and I asked my colleague, when are we going to finish collecting the data? It wasn't an MTurk, it was our own online pool. And she told me that we already had the positive mood condition completed, but we are still waiting to get people to the negative mood condition. And I asked, how is that possible? I mean, we assign them randomly after they start the study. And then she explained that the people that we assign to the negative mood tend to quit the study, and so we need to wait for this condition to fill up. Well, okay, that's a problem. Okay, that means that for every person we assign to positive mood, we are getting that person to do it, and for every person that we assign to the negative mood condition, well, only about a quarter of the people stay there. They ought to be different than the people that we assign to the positive mood condition. When I mentioned this to Hautian, he said, oh, well, this reminds me of the Donald Campbell's 63 paper, basically identifying the 8 what we call demons, and what Donald Campbell called the variables that undermine internal validity. And basically, the demo number 7 is that experimental mortality, or a differential loss of respondents from the comparison groups, is a problem for the internal validity of the experiment. Now, experimental mortality is a very colorful expression. No one actually dies from this. But nevertheless, that's a problem. And let me show some data on that. So back when we ran all our research in the lab, we were spoiled by absolutely no attrition. There is no attrition in the lab. If you don't believe my intuition on that, we actually looked at 82 studies that were ran in our lab at the University of Chicago by 46 different research teams. There was basically zero attrition in almost all of them. There were only 3 studies that had some people leave, and the most was less than 5%. When we transformed to the web, we assumed the same. And when you look at published papers, they never report attrition. We actually looked very carefully. We looked over a period of 2 years over the almost 300 papers in JPSP that included MTurk studies. Only 6 mentioned that there was some attrition, and none of these 6 papers mentioned attrition by condition. So the assumption is basically that there is no attrition also online in these papers. Now, that did make sense to us. That, for one thing, didn't match our experience with this mood study that initiated the investigation. And also, we thought, well, you know, there is really low sunk cost for quitting an online experiment. You can just try this experiment. You just do a few clicks. I ask you to do something that you don't like. Well, you leave. Okay? It's not a lab appointment that you had to make. Also, there was really low social cost for leaving. When was the last time you felt guilty about dropping a website? Okay? You just switch to something else. Okay? It's just not interesting. It's not what you would like to do. It's very impersonal. The person that is starting a study doesn't like it, doesn't feel that it's a bad thing to drop the study and go do something else with their life. So we decided to look at attrition, and the first thing that we did was asking our colleagues at the University of Chicago to send us the most recent MTurk studies that they ran. We collected 88 studies with over 22,000 participants, and we found out that there was one study that didn't have attrition. Okay? Basically, all studies have some people drop out. Okay? Whereas in the lab, there was only one study. There were only 3 studies that had attrition. Here, we only had 1 study that didn't have attrition. And what really bothered us is that for 1/5 of the studies, we had attrition that was greater than 30%. Okay, we also looked at the characteristics of these studies and thought at that point that we can pretty much identify when we should expect to see the problem. And so we basically ran replications of 6 common paradigms for social psychologists. We ran it online, looking to see what would be the attrition. And here's the data, and what you see here is the data for term management, control level, power, regulatory focus, ego depletion, and elaboration mode. And what is interesting about all these manipulations, all these paradigms, is that they involve asking the participants to generate some responses. That is, you give this open essay, and people have to write something in it, and we kind of know that that makes 30% drop just there. Okay, and indeed, if you look at the dropout rates, they are usually around 30%, which means that we don't really know if we are getting the same people, let's say, in the high power versus low power conditions. Okay, maybe all the low power conditions drop the high power condition. Okay, sorry, the low power people, the people that feel powerless, drop the high power condition. Okay, we don't know why 30% dropped. What was in particular bothering are these instances where we found that selective attrition such that more people are dropping one condition versus another. So with ego depletion, we had one condition where we asked people to write an essay that was rather depleting. We asked them not to use the letters A and N. 77% of the people dropped. Okay, if we ask people to do something easy, only 22.8% dropped. Okay, that suggests that in the ego depletion condition, we are only getting the people that are highly motivated, maybe highly energized to stay. Okay, the rest dropped the study. Same thing for elaboration. When you ask people to explain the reason for their attitude, then 33% drop. When you ask people to explain the mechanism for the phenomenon that you are studying, then 60% drop. Okay? You ought to be thinking that there must be something different between these two groups. They are no longer randomly assigned. You can no longer assume that they were similar to begin with. So dropout rates seem to be very prominent. Sometimes the number of people that drops is different across conditions. And then we ask ourselves, well, how come no one notices this? How come this is not being reported? And we think the reasons are that often people don't even notice this information. If you, on Qualtrics, for example, don't close the survey and look at the data after you close the survey, you might not even get it. Okay? So this information is never in your data file. We also think that it's very easy to ignore these people because we don't pay them. And in a way, we asked MTurk to give us 50 people per cell. We got 50 people per cell. Okay? We don't think about the fact that in one condition that could be 50 out of 50, and in another condition that could be 50 out of 500. Okay? All we care about is that we got the numbers. All right. So then we decided to be a bit playful with this and see how we can get to surprising yet false research conclusions. So first question, can doing more feel like less work? Okay, here we ask people to recall either 3 happy events from the past year, this is one condition, or 12 happy events from the past year. This is in the other condition. Okay? Now, we know that asking people to generate events is going to cause many people to drop the study. Even asking people to generate 3 events made 26% of our participants drop the study. But asking people to write 12 events, well, then almost 70% of the people drop the study. Now, again, when they drop, then other people come in. So eventually, you get the numbers right. But 70% of the population is saying, no, thank you. Now, if you compare it to the lab, no one would ever leave your lab because you ask them to write down 12 happy events. Okay? They will do it if you ask this online. Now, what was interesting is that then we asked them how difficult was the task, and what we find is that the people that wrote 3 events say it's more difficult than the people that wrote 12 events. Now, this, of course, cannot be possible. It cannot be that writing 3 events is more difficult than writing 12 events, given that writing 12 events is basically repeating the 3 events task 4 times. The reason that we get this effect is that the very few people that are willing to write about 12 events are probably really happy people, okay? Or that their bar for identifying an event as happy is very low. Here's another example. Can imagining applying eyeliner help one lose weight? Well, according to our data, it could. What we did is asking people in one condition to imagine applying eyeliners, in another condition to imagine applying aftershave cream, and then they have to describe how will they do it and how will they make them feel. And given that this is a generation task and there is an open essay at the beginning of the survey, then we get around 25–30% dropouts in both conditions. Actually, the difference here is not significant. In both conditions, we have people drop to the same extent. However, not surprisingly, men don't like to envision themselves applying eyeliners. And so they drop this condition, and so we get disproportionately more women in the eyeliner condition than in the aftershave condition. We then asked them to report their body weight, and we found that the people in the eyeliner condition weigh less than the people in the aftershave condition. Okay. Presumably, they lost weight just because they were envisioning engaging in feminine actions. Here's my last example, and I have many more that we ran because we really liked playing with this. This time we were going to test a hypothesis that is plausible, okay, that could be right, except that we can find evidence for this just by playing with attrition rates. Okay? So basically, the data seem to support something that is reasonable, but really they don't. So the question is, can deliberation increase support for restriction on gun ownership? And what we did was asking people to first report their attitude toward gun ownership, and then either write an essay explaining the reasons, or not do anything and just move to the next question. The next question was, again, to report how they think about gun ownership. And we used 2 different questions, so they're not actually answering the same exact question, but they are rather similar. And what we thought is that when you ask people to write open essays, you get the people with lower education to drop, and we know that there is correlation between support of gun ownership and education in the US. Basically, what we find is that when we ask people to explain their attitudes, then 36% of our sample drops. When we just present 2 questions, that between these 2 questions, this is the control condition, no one quit the survey. And then when we ask them about their agreement with pro-gun statement, then it seems that those that wrote the essay have a more negative attitude toward that than those in the control group. In a way, the essay biased the sample toward more liberals, which could account for the effect on supporting gun rights. Okay, so we were hopeful that we can do something about that we can decrease attrition rate. We tried a few things. One strategy that worked, and we reported in our paper, is a cocktail strategy where you warn participants before they start the study that they are going to have to do certain things. They are going to have to write open essays. It's going to require some thinking and so on. You appeal to their values, to their conscience, telling them that dropping out would have negative impact on your data. Also, you ask personal questions that make the person feel that you really need their data because you ask them about their personal lives. Was it effective? Well, in one study where we used construal level manipulation, writing an open essay about abstract versus concrete actions, it reduced attrition rate from 50% to 20%. 20% is not great, but it's much better than 50%. 4 recommendations, and we elaborate in our paper: minimize condition-dependent attrition, get insights into the cause of condition-dependent attrition, increase awareness, and what I think is the most important for us is that people will report that. It's something that we should be aware of. It's something that almost always happens. We would like people to start reporting in their studies whether and how many people dropped the study before completing it. Thank you. Do I have time for questions? We have 2 minutes for questions. Or you can get a head start on coffee there. Yes. Well, if you don't assign people to conditions, then you don't have to worry about selective attrition by definition. Actually, one way to go is correlational surveys, although then you cannot include causality anyways. The other thing that we do often is repeated measures design. So we go to the same participants one time after another, and then only include the data where we have the same person in both conditions. OK. I think that everybody has to leave now, so I will be here to answer questions, also the rest of the symposium. Thank you very much for joining us this morning.